As you can see, our shader is working well. You can rotate the object anyway, and you can move it around as much as you'd like. And our shader works as planned. But we've got a problem. If we choose a different type of mesh for our shader, it yields it gives us unexpected results. As you can see, this isn't what we're trying to do. But for others, it works well, like the torus. It works as expected. And this problem is very simple. Basically, our shader uses a map of the object and colors half of that map in black and half of that map in white. But the problem is, not all meshes are mapped the same way, and we get effects like this. So we'll need to make a different type of shader to mitigate this problem. Okay, so let's make a different mesh, and let's make a box. Let's start with the shader material, and you can name it whatever you want. I'll just name it half, and let's see. Okay, so right, let's just move this here. Shift middle mouse to move our panning point, and yeah, we get what we want. So last time we used UV, but this time let's make use of the vertex. We're gonna use every vertex, every little vertex that make up the cube, and we'll just cover half of them in black, and see what happens after that. Okay, let's start by making our variable. Let's call this vector vec3 equals vertex. Basically, that's just how we gain power over the vertexes in Godot. And so, let's start with our if statement. If vector is less than 0.0, and let's make our curly braces. And in this function, we're just going to do the same thing we did last time. Let's make a color variable, vec3, and we're going to plug this into our albedo. Vec3 col equals vec3 1.0 1.0 semicolon. And in this function, we're gonna say color. Oh, let's make this x vector. Let's use the vector's x-axis, and let's make the color equal to vec3 0.0, and which is basically black. So now let's make our albedo equals color. And as you can see, we get something weird. Basically, it's just basically right now our shader works by looking for the line in the middle of the screen and splitting our shader by that. But it'll be easier to see if we just make this other cube less visible and we move our original cube to the middle of the scene by resetting the position. And now it's easier to see that there's an invisible line going through the middle of the screen. So you might be asking yourself why this is happening. It's basically because our mesh is split by our camera's x-axis. So it's split by basically just what we do. And that's not really what we want. We want the mesh to be split based on the world's x-axis, not by the camera's x-axis. So we just go here and we take this out. And so for this to happen, get the we need to use an inverse view matrix, and we need to multiply by our vertex. And basically this just means we're multiplying it by the inverse view. We're basically balancing it out. We're basically balancing it out. But we're basically balancing it out, but we need to make some changes because this is a vector form. Because this matrix, we need to change it up because this matrix is a 4 by 4 and our vertex is only a vector 3. So we need to make this a vector 4. And if you don't understand the maths, it's fine. I'll make a few tutorials in the future explaining the maths you need to become a game dev or just master shaders. So basically we're just adding another sum to this vector and we're multiplying this. So the result of what's in these brackets will be a vector 4. So we just need to get the x, y, and z out of this. And yeah, that looks much better. But there is still things we need to add. Right now, this is not perfect. It's far from perfect. If you notice this, you'll find if we try to rotate, you'll notice the shader stays exactly on the x-axis, and that's problematic. Even if we move the cube, you'll notice it's more dependent on the world space than the actual mesh. First, let's get rid of the position problem. First, let's make the vector variable equal to the vector variable. And basically all we need to do to fix our position problem is subtract the node position in the world. And that just basically adjusts our shader and makes it so it follows the cube. So if we move this forward, you'll notice the line that separates the black and white, it now follows the cube's position. Yeah, but this still doesn't fix our rotational problem. The rotational problem is a bit more complex. Yeah, so we need to get information from our vertex function because it actually deals with the mesh's movement. We need to use the model view matrix. And this just basically stores the information of how the mesh was moved around, the different positions of the vertexes. And so let's start by getting the information out of the first entry, x, y, and z. Let's store this in a vector 3. Let's call this x, and let's make this equal to this. And nothing really changes because we aren't changing anything in the vertex shader. We're just getting a value. So we can just copy this. And now let's get the y value. And let's make this 1. And now let's get the z value. And now let's make this 2. And now let's just make a variable here to store from vec3. I'll explain what this does just now. Okay, so basically we're we aren't doing anything in the vertex function like I mentioned. We're gonna move information from the vertex function and move it down the pipeline to the fragment function. And we're gonna use that information in the fragment function. So we're gonna store it in the rotation matrix. No, this should be a matrix, a mat3. So rotation equals mat3 x, comma y, comma z, semicolon. And now let's just go down to the fragment shader. And now let's get the vector equals transpose rotation multiplied by vector. And let's just see how that works. And it looks pretty weird. The reason it looks this weird is because we didn't normalize our directions. Okay, so let's go up here. Let's type normalize backspace, and let's just close that brackets, and we basically just do this for each one. Don't forget to add a bracket at the end, and zoom, and that. And also, let's not forget to change this from model view matrix. Model view matrix, which gives us weird results. We need to change these variables from model view matrix to model matrix. And you'll find that we get our finished product. And now let's change the mesh. Let's make it a cube. And yeah, I think you can just import any single mesh and this shader will work. Yeah, let's try the prism and we get something nice.